Okay, today we're going to talk about graphing cotangent functions. So the first thing we'll look at is the parent graph for a cotangent function. Okay, so let's just start off with y equals cotangent of x. And we will give ourselves the similar graph that we've been using for all of our other functions. All right, and we're also going to think about this as it relates to the unit circle. So I'm going to draw a quick unit circle up here for us to look at. So let's think about these values here. And as you can imagine, they kind of relate to what we did with tangent. So if we think about cotangent at 0. Well, if tangent is the sine over cosine, or y over x, then cotangent is x over y, or cosine over sine. So if we thought about doing x over y, if we think about these points, we've got 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So for this function, if we did cotangent, which is cosine over sine, it is x over y. Cotangent of 0 is undefined because we get 1 divided by 0. All right, let's take a look at cotangent of pi over 2. Cotangent of pi over 2 is up here. So when we do x divided by y, we get 0 divided by 1, and 0 divided by 1 is 0. Let's do cotangent of pi. So once again, if we do cosine divided by sine, x divided by y, this is also undefined. All right, let's come down to 3 pi over 2. This time we're going to get 0 divided by negative 1, and that is 0. All right, so we have some things that we know here. So we could come over and we could graph them. And we can think about how things repeat here. Now, just like we did with tangent, this doesn't give us much information. And because we know about the ratios, we know that these 45 degree, or pi over 4, is very helpful, because the pi over 4, the x and y values are 1 over the square root of 2, or you could call that square root of 2 over 2. For both of them, just the signs change. So when we do that ratio of cotan of pi over 4, we're doing the x divided by the y, and that is going to be a positive 1. When we do cotan of 3 pi over 4, that is going to be a negative 1. And it's going to repeat. So we can see that this pattern repeats down here. We do cotangent of 5 pi over 4. So that's a negative x and a negative y. So that's going to give us a positive 1. And cotangent of 7 pi over 4 gives us the negative 1 again. And then we could finish it off with cotangent of 2 pi, and that is once again undefined. So what we're going to notice, just like with cotangent, is we're going to find all the possible positive and negative values lie in between 0 and pi here. So let's take a look at what we need. Since they lie between 0 and pi, that tells us about the period. The period of cotangent, just like it was for tangent, is just going to be pi. The normal period is pi. Now, once again, if we had a b here, it would have to be pi divided by b. So we're going to go out to that 4th tick mark. We're going to label that pi. So this would be pi over 2. This would be pi over 4. We're counting by fourths, so this would be 3 pi over 4. And then we have the negatives in this direction. All right, So we know at 0 and at pi, we are undefined. So we'll go in and we will draw in a nice different color to make them seem important, because they are our asymptotes. That's a value where this function is undefined. So let's see if I can slide that over onto the axis. And there we go. There's our first asymptote. We have another asymptote over here at pi. And we have another one at negative pi. And I wrote that wrong. Let me go grab that eraser, because that is just negative pi, not negative 2 pi. All right, so now I have them labeled correctly. I have my asymptotes, and let's take a look at the points in between. So cotangent of pi over 4 is the positive one, cotangent of pi over 2, and cotangent of 3 pi over 4 is negative 1. So this is positive 1, positive 2, positive 3, negative 1, negative 2, negative 3. So this is how my tangent ends up looking. And so just cotangent. And just like with tangent, all those transformations work exactly the same. So I'm going to go in and I want to show you what this might look like if we were to take it to Desmos and graph both a tangent and a cotangent in the same graph. And let's see if this makes sense when we're done. So let's say y equals tangent of x, okay? And you can clearly see where all those asymptotes would be. I'm going to zoom in a little bit so we can just focus on a few. And now let's graph y equals cotangent of x. Now, so let's see if this makes sense. The one thing I can't do is switch this to where it's radians. I wish I could. But we can see how nice those two graphs work together, and it would be better if we could count on the axis by radians. Let's go ahead and just add. I'm going to do it in a different color here. So I'm going to lay on top of this cotangent. I'm going to graph y equals tangent of x, not tax, tangent of x. So with that one, it would be here, here, and it would go to infinity. And then here. And I want you to see, does this make sense? Because these are reciprocal functions. What is the reciprocal of -1? It's itself, so they're sharing a point here. What is the reciprocal of +1? It's itself, so they're sharing a point there. Now, when I do the reciprocal of 0, the reciprocal of 0 is undefined, and that's why from tangent to switch to cotangent, we have that asymptote there. Okay? With tangent, we had an asymptote here. But when we think about its reciprocal, we get 0. Okay, so you do have an assignment. The assignment is the worksheet that you can see online. It's already attached. I would like you to go ahead and try this. I do realize many of you may not be able to print it, but you can work the problem. So if you'd like to do this on notebook paper, you certainly can. Now, pay attention because I've mixed it up, sine with tangent and cotangent. Remember, sine and cosine have a period of 2 pi, but tan and cotan have a period of pi. So when we're working these problems, these would be 2 pi over b, these would be pi over b. So just go ahead and please work these problems on notebook paper if you're not able to print this yourself. And we will talk about especially our cotangent graphs when we return.